Hello, learners! Welcome to our Grade 10 Science lesson.
Ama namin, pakinggan mo po ang pagtawag namin sa iyong banal na pangalan. Basbasan mo po ang aming pagtitipon at kami kaluguran mo sa araw na ito. Pagyamanin mo po, Panginoon, at maging nakaayon sa iyong kalooban ang aming pagkikita-kita mula sa simula hanggang katapusan. Masalamin nawa namin ang layunin mong dakila sa aming buhay at maisagawa namin ngayon ang aming mga gawain na may kabutihan at pag-ibig sa aming kapwa. Kami po'y naniniklohod sa iyong harapan na kami iyong patnubayan at iwaksi sa aming kaisipan ang anumang masasamang kaisip, inggit at pakikipag-alit sa aming mga kasama. Bigyan mo kami ng sapat na lakas at katalinuhan upang may bahagi naman namin ang aming makakaya sa aming mga kasama sa pagtitipon na ito. Ilagay po sa aming diwa at puso ang pagmamahal na hindi naghihintay ng anumang kapalit. Bagkus ay bukas palad na magkakaloob ng anumang tulong. Panalangin namin ang lahat ng ito. Amen.
Hello, Martians! It's me, Sir Bonmar Aguila Cruz, and I will be your companion for today's wonderful sci venture. Are you ready to learn? Are you ready for today's learning journey? Great! So buckle up and get ready to laugh. Because in MRT-MHS, learning science is fun. Last meeting, we discussed about biomolecules and its four major categories: the carbohydrates, proteins, lipids, and nucleic acids. For today's learning activity, our main objective is to apply the principles of conservation of mass to chemical reactions. From the time we get up in the morning to the time we sleep at night, chemical changes takes place within us and outside. Plants grow through the process called photosynthesis. The food that we eat are being digested by our body. Raw materials are being converted into new products. New vaccines are being developed, like what we are experiencing today. And many more versatile and cost-effective materials are being made. A chemical reaction happens in everyday life, and it occurs everywhere on Earth. But the question is, how do we know when a chemical reaction took place? Let's find out. There are certain things that will help us identify when a chemical reaction has taken place. These are called the evidences of chemical reactions. We have the production of light, evolution of gas, change in temperature, change in color and odor, and lastly, the formation of precipitate. Are you ready to look for these evidences? Now, try to identify the evidences of chemical reactions in the following pictures. Let's have this first picture. Correct. The correct answer is evolution of gas. How about this one? What evidence do you think is shown in this picture? Good job, learners! The correct answer is change in color and taste. But what is chemical reaction? Chemical reaction is a process in which two or more substances react with one another to form one or more new substances. The starting materials in chemical reactions are called reactants, while substances formed after chemical reactions are called products. One good example of chemical reaction is baking. The ingredients like flour, sugar, egg, and milk are the reactants, and a delicious cake is the product. A chemical reaction is represented by a chemical equation. A chemical equation provides information about the elements and the number of molecules that are reacting, as well as what is produced in chemical reaction. This is an example of chemical equation. We have hydrogen atoms reacted with oxygen atoms to form water molecules. The plus sign shows the combination of the reactants. In this example, hydrogen and oxygen are the reactants of the chemical equation. The subscript tells us that two hydrogen atoms and two oxygen atoms reacted. The arrow sign directs the product of the reaction, which is the water molecule. Always remember this: a chemical reaction follows the law of conservation of mass. What is this law all about? The law of conservation of mass stated that mass is conserved in chemical reaction. No new atoms are created and destroyed. There was only grouping or regrouping of atoms. So, remember, in a chemical reaction, that's also mass of the reactants is always equals to the mass of the product. Now, let's check if this chemical reaction follows the law of conservation of mass. We will get the molar mass of hydrogen, oxygen, and the water molecules. To get the molar mass, multiply the atomic mass by the coefficient. The atomic mass of the element can be found in the periodic table of elements. The coefficient of hydrogen is 2, meaning there are 2 hydrogen atoms. And the atomic weight of hydrogen is 1 gram per mole. To get its molar mass, we multiply its coefficient 2 by its atomic weight 1 gram per mole. Now, the answer is 2 grams per mole. Now, using your notebook and your periodic table, can you help me compute the molar mass of oxygen? Great! I will give you 10 seconds, and your timer starts now. All right, time is up. Let us now check your work. The coefficient of oxygen atom is 2, and its atomic mass is 16 grams per mole. To get the molar mass of oxygen, we multiply the coefficient by the atomic mass. So, 2 times 16 grams per mole is equivalent to 32 grams per mole. Did you get the correct answer? Very good, students. Now, let's get the total mass of the reactants. 2 grams per mole plus 32 grams per mole is equals to 34 grams per mole. Now, can you compute the molar mass of water molecule? I will give you 30 seconds. So ready? Go! Oops! Time is up! Let's now check your work. For a water molecule, we have 2 hydrogen and 1 oxygen. To get its molar mass, we will first multiply hydrogen by its atomic mass, which is 1 gram per mole. So 2 times 1 gram per mole is equals to 2 grams per mole. Next, we will multiply oxygen by its atomic mass, which is 16 grams per mole. 1 times 16 grams per mole is equals to 16 grams per mole. Now, 2 grams per mole plus 16 grams per mole is equivalent to 18 grams per mole. So therefore, the total mass of water molecule is 18 grams per mole. Look, the total mass of the reactants is 34 grams per mole, while the total mass of the product is 18 grams per mole. Does this chemical reaction follows the law of the conservation of mass? What do you think, students? The answer is, oh no, oh no, oh no, 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 no. Yes, the answer is no. Why do you think so? Correct. Because the total mass of the reactant is not equivalent or equal to the total mass of the product. Now, what are we going to do? Do you have any idea? Correct. We have to balance the equation. Wait, class. Look, we got a message. And it's from Miss Clarissa Mulde. By the way, class, for your information, Miss Clarissa Mulde is one of my co-teachers in this school, and she is also teaching grade 10 science. Now, let us read her message. Hello, Sir Bon. I have heard that you are having problems with unbalanced chemical reactions. Do not worry because I have sent steps on how to balance chemical reactions. I hope it will help you and your students in your class today. Keep safe. Wow, that's great, ma'am. Thank you for your message. Now, let us balance the chemical equation. Here are the steps in balancing chemical equation. First, create a table and list down all the elements on the reactant side and the elements of the compound on the product side. Count the numbers of atoms that is present in each element by simply looking at the subscript. Note: an element without a subscript is automatically means that the element has only one atom. In this chemical reaction, the elements found at the reactant sides are two hydrogen and two oxygen atoms, while at the product side, there are two hydrogen and one oxygen atom. Observe that the number of oxygen atoms are not balanced. To balance the chemical equation, place an appropriate coefficient before the symbol or formula. Take note: do not change the subscript of the formula as it will change the identity of the components. In this chemical reaction, let's try to add coefficient 2 to the product to balance the oxygen atom. Remember that coefficient multiplies to both hydrogen and oxygen in the product side. Now, let's count and check if the number of atoms in reactant and product are already balanced. In the reactant, there are two hydrogen and two oxygen atoms. In the product, we will multiply the coefficient 2 to the subscript 2 of the hydrogen, which is 2. So the number of hydrogen atom in the product will be 4. And for the oxygen atom, we will multiply the coefficient 2 to the number of oxygen atom, which is 1. That gives us the total number of 2 oxygen. But look, our attempt to balance the oxygen resulted to unbalanced hydrogen. So, it needs to be rebalanced. Let's try to add coefficient 2 to hydrogen at the reactant side. Now, let's count and check if the equation is already balanced. In the reactant side, we multiply the coefficient 2 to the subscript of the hydrogen atom. So 2 times 2 is equals to 4 hydrogen atom. The number of oxygen in the reactant side is 2. While in the product side, there are 4 hydrogen and 2 oxygen atoms. So, is the equation already balanced or not? Yes, the equation is already balanced. Therefore, the balanced equation is 2 hydrogen will react to oxygen to form 2 water molecules. Very easy, right? Balancing equation is a trial and error. Just like in life, we need to try and do not stop until we reach our goals. Now, can you help me balance this equation? I will give you 1 minute to answer these. Your timer starts now. Great job, learners! Now, let's check your answers. The balance equation is we have 4 aluminum to be reacted with 3 oxygen to form 2 aluminum oxide. Very good, learners! Students, At this moment, you are free to write question in the comment section. I will be choosing two questions that I will answer. I will give you 1 minute to key in your questions in the comment section. Alright, now let me read the questions. The first question is from Faith Jewel Labutoy from grade 10 Magbanwa. And her question is, why is it not allowed to change the subscript in balancing chemical equations? Well, Jewel, the answer is, when balancing a chemical equation, it is really not allowed to change the subscript because when you do it, you are actually changing the substance itself, okay? Which will make your chemical equations wrong. Thank you for your question, Jewel. Okay, the next question is from John Benedict B. Bonavente from grade 10 Del Pilar. And his question is, why is it important to balance chemical equations? Well, okay, Benedict, a balanced chemical equation obeys the law of conservation of mass. This is an important guiding principle in science. It is important to balance a chemical equation to let us know the amount of reactants needed and the amount of products formed. Same with preparing a dish. It is important to know the exact measurement of the ingredients to get the desired taste of the product. Okay? Thank you for your question, John Benedict, and I hope I answered your questions. Students, your groupings last meeting will still be your groupings for this group work or performance task. The title of our task is Cooking is Science. You just have to search a famous delicacy or food from any parts of the Philippines. Provide a short background of that dish. While preparing that dish, create a video presentation of the procedures on how to prepare it, starting from its ingredients to its final product. Cite samples of chemical reactions, explain and share the science behind it on the class. Your output will be graded using the rubrics below. And take note, students, please seek guidance from your parents or guardians. And your TLE teacher will also give grades in your performance. Again, I am your teacher, Sir Bonmar de la Cruz. Thank you for listening in today's lesson. Stay safe, God bless, and see you next time. Bye!